In this chapter, we will learn about bivariate data and the statistics involved. In this lesson, we shall learn about bivariate data and their correlation. Bivariate data refers to two random variables, one being controlled, which is the independent variable, and one that changes its values when the independent variable changes, which is known as the dependent variable. Now, correlation is simply a statistical dependence and relationship between two random variables, and it does not equate to any causation. This means that it doesn't mean that an increase in x causes an increase in y. It simply shows a relationship that as x increases, y increases as well. Now, since we are on the topic of linear correlation, bivariate data can either have a positive correlation, linear correlation, as shown in the first graph, or it can have a negative correlation as shown in the bottom graph. So for positive correlation, when your x value increases, your y value increases as well. For a negative correlation, as your x value increases, your y value decreases instead. Do take note that some bivariate data do not follow any linear correlation and instead can be modeled by other non-linear models, which we will discuss in the next lesson. Most questions on linear correlation will ask you to sketch the plots of the points given. Typically, the data will be presented in a list format. So go into your list function under your GC, which is in stats and edit, and key in the numbers into the lists. Typically, I will key the x values into L1 and the y values into L2 so that I will not be confused with them. From then on, press second and go into stat plot. Okay, go into the first one, and you have to turn this stat plot on. Select your x list and y list. So your x list would be the independent variable, your y list would be the dependent variable, and press graph. And you should be able to see something like this. So it's the rough position of the plot. But something to take note of is that if you do not see the whole plot, so you do not see, like for example, I keyed into 6 points, and you do not see 6 points, click on zoom and go to zoom stat, which is option 9. For a scatter plot, take note that you have to label some important points, which by labeling it would be to write down the x and y value. So for this, it would be the smallest x value, so this point you have to label, the largest y value, so this point you have to label, the smallest y value, so this point you also have to label, and lastly the largest x value. So all these points are points which you have to write down the value, and do not forget to include your x's. The last thing that we'll cover in this lesson is the PMCC, which is known as the product moment correlation coefficient. The PMCC's formula is actually given in the MF15, but for most instances using a GC would be sufficient. Now, typically, if a PMCC value is closer to -1 or 1, then it will be a strong linear correlation, with negative being a negative correlation and positive being a positive correlation. Now, to use your GC to calculate the PMCC, same thing, you will have to key into your lists already, go into calculate and go into linear regression. My calculator does not show it, but when you click on linear regression, you should be able to choose x and y. So choose the list 1 and list 2 respectively, and when you press, you should see something known as R, and this would be the product moment correlation coefficient. Now, to recap, we have discussed the definition of correlation and positive and negative linear correlation. We have also talked about the PMCC and its use in determining linear correlation strength. Something to take note of finally is that do not always rely on PMCC to determine the correlation strength. Always refer back to the scatter plot instead.